In this video, what we're going to look at is the process of integrating trigonometric functions. Now, in the differentiation unit of the course, we've covered taking the derivative of trig functions and how that works. What we're going to look at is the opposite of this, so we're going to integrate them. Now, think back to when we did it. If you remember, d by dx of sine x, so the derivative of sine x was cos x, and d by dx of cos x, so the derivative of cos x, was minus sine x. When we're integrating these and reversing this process, it's actually quite a straightforward thing. But there is a big point that you have to know and a big difference. The integral of cos x dx equals sine x plus c. Again, this constant of integration has to come into play. And the integral of sine x dx equals negative cos x plus c. And that's the big difference, is the negative. If you look, derivative of sine goes to cos, but and the derivative of cos goes to minus sine, but the integral of cos goes to sine, and the integral of sine goes to minus cos. And that's to counteract the difference, because remember, integration is the reverse process of differentiation. If I was at this one here and I differentiated it and got to the minus sign, if I was to reverse the process and get back to cos, I've got this negative that's now appeared that I have to take into account, which is why the integral of sine x is negative cos x. And if I do the same sort of process here, derivative of sine to get to cos, and I want to integrate and get back to sine, there's no extra negative that has to be taken into account, which is why the integral of cos x is sine x plus c. Don't get these confused. Okay, don't get these confused and mixed up. Remember the way that they go. And if you need a bit of a prompt, they actually appear in the formula list for the exam. Fingers crossed though, you won't need that. Let's have a look at a couple of examples to see how we work with these. So let's imagine dy by dx equals 3 sine x, and I want to calculate y. Well, we know that y equals the integral of dy by dx with respect to x. So all I need to do is substitute into the integral and then calculate it through. So what I want to do is calculate the integral of 3 sine x dx. Now, when we're working with one like this, remember the constant in front, we just write it down, and then we multiply it by whatever we get as the integral of the main part of the function. Now, we've got sine x here. Remember, the integral of sine x is minus cos x. And because it's an integral, we have to include our constant of integration, our plus c. Then it's a case of simplify this part that we've got here. So we've got 3 times negative cos x, that gives me minus 3 cos x, plus c, my constant of integration. Similarly, if you get asked a question of this form, so if f dashed of x equals negative 2 cos x, calculate f of x, we just remember the same sort of thing. We just remember that f of x equals the integral of f dashed of x dx, substitute in, and solve it. So we know it's the integral of negative 2 cos x dx. And again, it's the same process. What we start with is we write down the constant here. So we write down our negative 2, and then we multiply it by whatever we get here as our integral. Now remember, the integral of cos is simply sine x. And we then have to include our plus c, our constant of integration. We then simplify, so minus 2 times this, quite simply minus 2 sine x plus c. Integrating these functions is straightforward. It's actually quite nice and easy when it's just a simple sine or a cos. However, they can up the ante a little bit and start to insert linear functions here and functions of other forms. But these follow similar formats to when we were calculating the derivatives. So the integral of sine of ax plus b and the integral of cos of ax plus b, both with respect to x. Remember we did the derivatives of these. This is just again reversing the process. Our signs don't change. The integral of sine is still minus cos. The integral of cos is still sine. It's just this extra little part that comes into play with the ax plus b. For the integral of sine of ax plus b dx, it's negative 1 over a cos of ax plus b plus c. This 1 over a comes from the fact, remember, you've got to take into account when you're calculating the derivative, it's your trig part times the derivative of this. So we have to take this into account to get rid of it, which is where the 1 over a comes into play. Similarly, with the integral of cos of ax plus b dx, we have to take this into account again, which is where it's 1 over a sine of ax plus b plus our constant of integration at the end. This has to be brought into mind. We have to make sure we account for this. So again, a couple of examples, so this is just to illustrate it. Calculate y of dy by dx equals sine of 4x plus 1. Again, remember the fact that y equals dy by dx, so we're calculating our integral. Substitute it in, so we get the integral of sine of 4x plus 1 dx, and then it's a case of solving it using the form that we know. So it's sine of 4x plus 1, so it's this one here, sine of ax plus b. And in this case, a is 4, b is 1. So integral of the sine part just gives you minus cos of 4x plus 1. But remember, we then have to multiply it by this bit here, the 1 over a. And in this case, a is 4, so it's times a quarter. And we then have our plus, our constant of integration, c. And then it's a case of simplifying. So we get minus a quarter cos of 4x plus 1 plus our constant of integration at the end. So that's how it comes out there. It's actually straightforward. It's just like the derivative one. The only thing you have, well, one of the major things you have to make sure of is you get this bit right here in front, along with the signs. And that's even the case if it involves radians. So if we start to bring in pi over 5s or any other form of radian function. So imagine I want to calculate the integral of cos of 3 over 2x. So cos of 3 over 2x plus pi over 5 dx. Again, it's the same process. Integrate the trig function part first, and then this bit in here. So the integral of cos is sine, so we get sine of 3 over 2x plus pi over 5. Keep that bit the same. We then multiply it by the derivative of this in here underneath the 1. So remember, it's a fraction, so it's 1 over the derivative of this. So it's 1 over 3 over 2, then plus c. Now, 1 divided by 3 over 2, this bit here, 1 divided by 3 over 2, is the same as 1 times 2/3, which is 2/3. So this times 1 over 3 over 2 is the same as saying times by 2/3. So when we simplify it, we get 2/3 sine of 3 over 2x plus pi over 5 plus our c. Don't forget that. We have to include that constant of integration. When we're integrating the trig functions, they're actually very, very similar to the differentiation process with trig functions. We just have to make sure we take into account that when we're reversing this, the negatives have a play. So the integral of sine is minus cos x plus c, and the integral of cos is sine x plus c, rather than when we're taking the derivative, and the derivative of sine is cos, and the derivative of cos is minus sine. Watch out for that little trick. But again, these will appear in the formula list, so you've got that little prompt and reminder if you require it. Fingers crossed though, you'll have memorised these by then and you won't need that.